Hey, notes out, labeled 8.1, quadrilaterals. Put the date in the top right-hand corner. Today is the 21st. Quadrilaterals. Does anybody know what the word quad means?
Four.
Okay.
Coach Tom,
Yes.
that's wrong.
What's wrong? Oh, my bad. 8.1.
When I say like,
Thanks, Jacob. Quadrilateral is a four-sided polygon. What was a triangle? How many sides? Okay. How many sides is a pentagon? Five. Okay. Quadrilaterals have four sides, and what we're going to do is we are going to talk about all the different kinds of quadrilaterals in this chapter. This will be your easiest section, just kind of introducing you to them. Okay? We're not going to talk about any special types of quadrilaterals just yet. It's actually a pretty easy section. If you look on page 310, they have some quadrilaterals drawn. You don't need to write this down, but if we were looking at these pictures, do you see why this is not a quadrilateral? This one right here that I'm pointing at. Why? It has more than four sides. It actually has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Same thing here, right? This one's curved. It's not even a polygon. Neither is this one. This is two triangles connecting, isn't it? But it's not quadrilateral. Here, even the ugly one, this one has how many sides? 1, 2, 3. 1, 2, 3. 1, 2, 3. Even this one is concave, but it still has 1, 2, what? 3, 4. Easy peasy, right? Okay. One thing to talk about, if I drew some sort of a quadrilateral here, first of all, how would I name this? I would just call this A, B, C, D. That's all you've got to put. All I did is name the vertices, didn't I? Okay. We don't have to put like a square or a four-sided figure in front of it or anything. By the fact that we named four vertices, we are saying it's a quadrilateral. And you need to go in consecutive order. Consecutive, what are the sides? What's the side consecutive to A? What's the next side? Or I'm sorry, next vertex. B. Or, so I could have named this A, D, then what? C, B. You would name it how you would tell someone to draw it. Go to here, then what? Go to here, go to here, go to here, right? You could start at B. There are a lot of different names for this, isn't there? Okay. Special sides. Do you guys know what, if I was to draw this right here, do you guys know what that is called? DB is called a diagonal. Okay? How many diagonals do you think it's possible for me to draw on a quadrilateral? Where else could I draw the next one? So I'll draw AC and say AC and DB are called diagonals. Oops, tell me when I'm zoomed in too far. Diagonals connect are segments that connect non-consecutive vertices in a polygon. Can anybody tell me why we didn't talk about diagonals when we were talking about triangles?
Because we have medians.
Ponder on that for a second. By definition, diagonals are segments that connect non-consecutive vertices in a polygon.
Because it's all consecutive, all the angles.
Exactly. In a triangle, if you were to draw a triangle, and I'll draw one, but you don't need to draw it. Right here. Is there a non-consecutive vertices to point A? In other words, to get to the other points in the figure, I could always get through it by going on the outside, correct? However, with a four-sided figure, from B, staying on the quadrilateral, I can get to A, I can get to C, but how would I get directly to D? I have to walk inside and across, correct? And that's a what? Diagonal. Can't be any diagonals in a what? Three-sided figure because they're all connected. Okay? So that's why we didn't define diagonals when we were talking about triangles. So we understand what diagonals are. Next big part of this, really the only thing left for this section. Excuse me? Just be quiet. In a triangle, the interior angles sum is what? Everybody agrees with that, correct? In a quadrilateral, the interior angles sum is, what do you think?
360.
Turns out they add to 360 degrees. So in this picture, x plus y plus z plus w would equal what? Three-sided figures, the interior angles add to 180. Four-sided, they add to 360. When you get done writing that down, get out our worksheet.
That's done.
Does that have anything to do with math?
Yeah.
Okay.
180 is like the halfway speed, right?
Mhm.
Yeah, all right.
Court, you got this written down?
No, sir. I don't even have the right book. You say he's gonna give me a book.
That has nothing to do with writing the notes down. All right, everybody got this down? Let's look at our worksheet now. Court, you'll have to copy it down when we're done.
Or you can get mine if you need them.
Shut up. No, you're just trying to talk. Just trying to make sure everybody hears you. Shh. Name a side that is consecutive to JK.
JN.
Consecutive, what would that mean?
Across from?
Think of it like this. No, that would be opposite. Consecutive means, in essence, as you, I know you guys love my stick figures, if I was walking along this, a consecutive side would be one that I would get to without having to walk inside of the next one. Consecutive, you can think of the next one. What's the next side going this direction? Or what else we could, if we walk the other direction, what's the next consecutive side? So that's what consecutive means, the next one. As you trace the figure. Because this is the inside of the figure, it's not the actual figure. So the next side on the figure as you draw it would be JM. If you went this way, the next side would be what? KL. That's why they're consecutive. Consecutive in essence means the next one. Now we're going to say name a side opposite KL. There's only one possibility, isn't there? Because it's consecutive with these two and there's only one left. So JM. What are these questions doing? Trying to teach us the language, aren't they? Understand what they mean when they say opposite. Understand what they mean when they say consecutive. Name the vertex that is opposite L. Okay, now we're talking about vertices. We're not talking about sides, but does the same thing kind of, the same concept work here? Consecutive means the next one. As I was on this angle, the next one would be what? If I went this direction, the next vertices would be what? Oh, sorry. As if I was walking on this, the next vertices would be what? K. If I was walking this direction, the next vertices would be what? So which one would be opposite? The one that I have to walk across to get to, which would be J. Okay? Name a pair of consecutive vertices. Well, I say name a pair, so they're not telling you where to start, but they just want you to say two vertices that are next to or beside each other. I heard M and L.
J and K.
J and K would work. Any others?
J and M.
J and M. I'm okay with that.
K, L, and M.
K and L.
Yeah.
Is that all of them?
Nope. We got a couple more.
Well, I could have said L and M, but I've already said M and L. Right? I could say J and M, but I've already said J and M. I could say K and J. I've said J and K. Same thing. K and L, and I've said it. So that's all of them in there. Name an angle opposite angle K. Now instead of talking about vertices, we're talking about the actual angle. But does the concept stay the same? The next angle would be J this direction, and the next angle would be what? L. So the one opposite it would be angle what? Not so bad, is it? We ought to be able to do that, shouldn't we? We all sure ought to be able to write out the problem, which we better do. Now, what do you think they're going to deal with here? The measures of the angles. What do we know about the measures of the interior angles of a quadrilateral? They add to what? So what am I going to do here?
Add those three together and then subtract them from 360.
Right. The equation and how these relate to each other would be x plus what? That's an angle, right? X plus what? 97 plus what? 107 plus what? Equals?
360.
I want you guys to write that down just so you understand the relationship. I know that you can add those up, subtract from 360 in your head, right?
Yes, sir.
If you write that down, that's showing your work. You telling me you understand.
We gotta start work feelings.
Did I just say that? I said that I want to see this. I want you to show me that you know what the relationship is. That took me 5 seconds to write that down, didn't it? For 20 problems, that's 100 seconds I'm asking for. It's not much. Show me that you understand it. I know that you can do this in your head and in your calculator. Just show me you understand that these four add and equal what? 360. Okay. When those added together, what do you get? 292. Is that what you got? Is that what you guys got?
What? Adding them together.
When you added them together.
I didn't get that either.
No, they did get that. So, what's left? There's 68 degrees left for x, isn't there? Number 7, what am I going to ask you to do here? Write the relationship. X plus what? 66 plus what?
91.
91 plus what? Equals what? Now, the rest you can do with calculator work. Now, you've proved to me that you understand the concept. So now, you just add those up. 66 plus what? 130 plus what? 91 equals 287. So how much is left? 73?
Well, I thought it was 73 degrees. Sorry, though.
You guys done showing off? Okay. Now, for the next one. Why do you think, and guess what? You know the reason I've been having you do this up here? Now these don't seem so hard, do they? All you're doing is writing each one of these down, saying it, adding them together and saying it equals 360. So tell me what to write down here. X plus what?
2x
Plus, what's all that got to equal? So do you see why writing this relationship out, all of a sudden it's easier now, because all I did is, instead of having a number for the third one, right, it was 2x. So now I have an equation. I'm going to have some solving to do here, aren't I? Okay? Anytime an equation looks weird like this, there's probably some simplifying to do. Is there some simplifying to do here?
Yes.
Yeah. If it looks complicated, there's probably something to simplify. X and 2x. 85 plus 85 and 101. All that equals what? Now this is an equation you're used to solving, correct? What would I do?
Minus 186.
That's what 3x is equal to 174. Am I done?
Divide by 3.
What's x equal to? Okay, now here's the thing. My question to you is this the answer? I don't know, it may be. What does the question ask for? Find the what? So this is an answer. It's just not the what? Only answer, is it? It's what x is, and x is this angle, so this angle is what? So I found one of the answers. Just in this case, there's two answers, isn't there? I have to find, if this is x, this one is 2 times whatever x is, right? What is 2 times x? You just plug that in. How could you check and see if you were right? Add them all up and see if you get 360, right? Not so bad, huh? Number 9. What would I write down? Tell me.
X plus 67.
Plus 67 plus... Does it matter what order you put it in? No, because we're adding them. Now, add those up, subtract from 360, tell me what you get. You get 258, you subtract from that, you get what? Is that what it asked for? Okay.